Alright, we're going to start by creating our environment, but first let's do some initial project setup. So just go to File, and we'll create a new project. And then you can navigate to wherever you want this project to be. In my case, go to E, Visual, Vertex. Okay, then I'm just going to call this project Creepy World, just for the sake of example. And then hit accept. And that's going to be the location where your project is going to be saved. And then for the project name, this will be an additional folder that contains all of your Houdini work. And I like to just call this Houdini. You can see the path that it'll be creating here. So if you just hit accept, you can leave all the default folder names there. That's all fine. Then if we look at our file system here, we can go to our Creepy World project, and we have a Houdini folder with all of those various default folder names. And I like setting it up this way because then if we want to have a separate section in here for comps, we can do that. Or any other, maybe other programs that we want to create extra elements in. Maybe you want to do some things in Photoshop, and you can make folders for that. And I think it's a decent way to organize the project. Then once you've set that project once and you've reopened Houdini, you can come back to it in your recent project lists here. So I'm just going to use the project that I already have made previously. Alright, now most of the time in this class, we're not going to be using the shelf tools. We're going to really build things node by node, but the one exception here is going to be the terrain itself. For this, I often like to start with one of these examples and then build upon it from there. For this particular example, we can start with perhaps the Terrain Hills preset, and this will create a lot of the initial nodes that we need to build up this terrain, and then we can tweak it from there. Now, I don't want to spend too much time diving deep into terrain generation, because really this is an effects class, and I want to focus more on the proper effects techniques rather than just world building. But there are a lot of interesting things we can learn from this terrain example, and the height fields that this utilizes are relevant to various types of simulation effects as well, as I will explain later. So if we take a look at what's going on in this height field example, I'm going to just hide this parameter view here. Sometimes I like to keep that hidden, and I'll press P to bring up this kind of side parameter view here. And this is a little bit nicer, I think, when you really want to have a good view of all the nodes you're working with. Kind of maximize your screen real estate. So this preset for the Terrain Hills is going to start by creating a height field. Now this looks like just a flat grid, but this actually represents a 2D volume. So what that means is, if we just create a grid, and by default this will be polygons. Let's maybe display that grid, make this the same size as the height field. See, this height field is 1,000 units wide because this terrain work tends to be meant for, large scale scenes. So I'll just quickly make this grid 1,000 units wide. These are polygons. If you middle mouse on that grid, you can see this is made of 100 points, 81 polygons, etc. This is a regular 3D mesh. Whereas this height field, if you display that and middle mouse on it, you can see this is made of 2 volumes. It says 2 points and primitives and vertices, and those aren't like regular 3D mesh points and primitives. These are just essentially basic points and primitives that hold information about the volumes. You can see in this middle mouse view that these are the 2 volumes down here. One is called height and another is called mask. And as I mentioned, the points and primitives really just store extra information about these volumes. And you can see that if you go into the spreadsheet here, you can see the position, that's just positioned at the origin. If you look at the primitives in the spreadsheet, you have a name attribute that's just giving us the name of each volume. So it's not real geometry, it's just a 2D volume. And I suppose this is a good time for me to explain, a 3D volume as well. Now, just to explain 3D volumes quickly, I'm going to create our classic pighead test geometry and display that. And there are a couple different types of volumes that we can create in Houdini. There are Houdini native volumes, and then there are VDB volumes, and they're essentially just different ways of storing this 3D volumetric data. In this case, we're going to use VDBs, and that tends to be the volume format that's most used in production settings. And we can create these VDB volumes by just typing in VDB and going to our VDB from Polygons node. Drop that after the test geometry, and you can see this voxelized representation of that geom. Now this looks like it only stores value exactly where our geometry was, but it's actually storing information inside the entirety of this volumetric box that it's created. So this volume here, it's represented by that box that's hopefully not too difficult for you to see. This whole space contains information about the distance of each point in space from the surface of the geometry. So for example, this position might be 1 unit away from the geometry. This position might be 2 units away from the geometry. And this also happens inside the geometry itself. So these values will become negative when we go inside here. It's essentially a negative distance when we're inside this thing. See, will it look like anything if we go inside? Yeah. So now inside here, in this VDB, this is storing these distances as well. So maybe this is a value of -1, because it's 1 unit inside the geometry. Maybe this is a value of -2, because it's 2 units distance inside the geometry. And that's what an SDF volume is. We're going to utilize these quite a bit throughout the class. They're very useful for various different situations. There's also a different type of VDB volume, which is called a fog VDB. So in this VDB from Polygons node, you can turn off your distance VDB, which is another term for SDF. And you can turn on the fog VDB here. And this is going to default to create a volume called density. And sometimes these fog volumes can be a little bit hard to see on a light background. So I'm just going to hit D, go into my display options, and we're going to go to background, color scheme, and set that to dark. That tends to make it easier to see some of these 3D volumes. Now this one is a little bit different because it's not storing the distances from the geometry like the SDF was. This is storing explicit values inside, all of this area that the geometry encompassed. In this case, these are density values, and it's just going to default to giving us a density of 1 for all of these points, and it's going to give us a density of 0 in all of this empty space here. And you'll see as we get further into the class various things that we use these different volume types for. I don't want to get too far into that right now. I just want to bring this up to kind of highlight the difference between these 3D volumetric representations and a 2D volume. Now if we go back to the height field volumes used to generate this terrain, you can see that this is much different than those 3D volumes that we just looked at. These height field volumes are almost more like images, really, just storing various values in space on this 2D plane. And by default, a height field is just going to get initialized with some sort of uniform value. It's just defaulting to a height of 0. You can kind of change that initial height if you want. Set that to 500. We have a different initial height. Now, this is just a boring plane at the moment. Set that back down to 0. And let's step through the various operations being applied to this height field. So this hills preset starts by using a noise on these values just to get some interesting breakup of those shapes. And this is using a pretty large scale element size with some large amplitude. You can tweak this to your liking. If you reduce the element size, you get lots of fine detail. And if you reduce the amplitude, that'll change the height of that detail, like so. And this doesn't really look like realistic hill detail just yet, so we need to do some extra processing on this to make this look more like realistic terrain. So we can apply extra layers of noise for more interesting detail, and it's worth pointing out that all of these different height field noises are not actually changing things in 3D space. So if we have 3D geometry like a sphere, make this a bit bigger, and we'll make these polygons of a higher frequency. This sphere, we can apply noise to this as well. One of the classic ways of applying noise is just adding a mountain top on here. Let's raise the height and the element size, something like that. Now this is, moving the points in 3D space to apply this noise. But these height field processes, even though this is displayed in 3D space, it still is only really represented by an underlying image. So essentially, to better represent what each of these height field noise nodes are doing, we can take a look at what that might mean for a grid representation of what that height field data is really doing. So if I create a grid, let's make this, once again, 1,000 units wide, maybe a few hundred rows and columns. Now, essentially what we're doing here with these height field noises is we'll start by adding an attribute noise, which will default to changing the color. Color is usually a vector attribute with red, green, and blue values, but I'm just going to change that to a float to make it black and white to better represent the type of data in a height volume. So we can start with a very large element size. Let's try 300, see what that looks like. And then in the fractal, maybe turn down the octaves for a more simplistic noise here. Okay, this essentially is what this initial height field noise is doing. Now, when we're displaying the height field in our viewport, this Houdini knows to take these values in this 2D plane and use those height values to display the actual heights of this surface. But, as we're applying additional noise, it's not like noising up geometry. This isn't taking this simple shape, and it's not like, displacing points to add detail like this. All this is really doing when we add this extra layer of height field noise is it's processing these, flat 2D height field values with some extra detail in those values. So we're essentially doing another attribute noise like this. Once again, we'll just call this float. Give this an element size of, 30. So yes, going from here to here is just modifying those height field volume values to do something like taking this to this. If we just bring up this amplitude like so. So, the height field itself, it's just storing these simple values like that. And it's just being displayed accordingly afterwards. That's why height fields are quite efficient to work on. If we were to make extremely high-res geometry like this, with tons and tons of points to represent this terrain, if we wanted to add a little bit of extra noise to this, and we were doing it just with a regular polygon mesh, that can be very heavy, very slow to process. And because these height fields are really just these slices of values, it's really fast for Houdini to compute this, rather than, this is a pretty simple sphere. But, as you start to get more and more dense polygons, whoops, might not want to make that 2000. As these polys get really dense, it gets much heavier to process. So processing things in this way is much faster. Actually, before we move on, I can show you an additional node that's very helpful for checking the actual values in the volume, and it might help to improve your understanding of what these volumes are doing as well. There's this volume slice SOP. That's super helpful. So we can connect that to our height field here. And in the source group, we can tell it to specifically look at either height or mask. In this case, I'll tell it to just look at the height volume. Don't care about the mask volume at the moment. And then there are different ways that you can visualize this. Right now, the visualization range is from 0 to 1. So that's why this is looking extremely kind of clipped to just a couple different colors. But this volume slice is actually outputting geometry. You can see this is a mesh with 250,000 points. So this is, it's a pretty high resolution mesh here. And we can look at the spreadsheet, and it's creating an attribute with the actual values that's coming from the volume. By default, this attribute is called density. We can change that to be called height. And these are the actual height values that are stored in our height field. And it's just being applied as an attribute on all of these points here. Now, if we click this height column, that can sort all of the points by the height value. So it looks like our ranges go from -10 up through almost 170. So let's set our visualization range to -15 for a little extra up through 170. And this will give us a better representation of what the actual, volume height values are. And another kind of interesting thing is that now that we have all of these volume values being applied to these points, we can do something kind of interesting just for the sake of example, where we use a simple line of vex inside an attribute wrangle to set the y position equal to that height value. So at p.y is the y component of the position equals this height attribute that we've just set. So here we've got these polygons with point positions being set based on that height attribute that they've sampled from the volume via this volume slice SOP. And this really matches perfectly with the display that Houdini is giving us for the height field directly. So hopefully this can help you to understand, this is really a representation of the height field values, and this is just how it's displayed. And yeah, we've got our points doing the same thing. And of course, we can also use this volume slice to view any other type of volume as well. If we look at our pig head that we took a look at earlier, you can see that this fog volume, actually this is the SDF volume for the pig head. We can do a volume slice on that. And as I mentioned earlier, if you look inside the spreadsheet, these values go from positive to negative, depending on whether the point is inside the surface or outside it. And then similarly for the fog VDB instead, these are just density values. If we look at the volume slice values for that, now we get values between 0 and 1, which is what we expect for density when we look at the volume slice here. So yeah, this is a very helpful node for kind of investigating what's happening in a volume. It could be helpful for debugging things, or yeah, maybe even getting creative with it. So yep, definitely a helpful one to know. So we've applied some basic shapes with the hills noise here, and then added some extra detail to those height values with the roughness noise here. But if you look at the next stage, the one labeled dirt, that's not applying noise to the height values, that's instead applying noise to the mask volume. So if you remember, this height field node at the beginning is creating two volumes, a height volume and a mask volume. And it's setting values on both of those to 0 by default. But now we have some values for the mask as well. And the reason we're doing this is because we want to kind of simulate some dirt piling up in the crevices of this terrain. That's going to make this look a lot more realistic if some of these recessed areas kind of have a little bit of that material piling up. Now right now it's kind of looking a little bit too angular and not as organic as it could. Now this height field slump node is pretty cool. That kind of simulates material flowing down the slope of the surface. Now, I know I keep reiterating this point over and over again, that all of these height field operations are not doing this stuff based on 3D space. This is all represented still by these 2D volumes that I keep calling images, because that's really kind of what they're like. Coming back to this here, this is figuring out the slopes that the material should flow down based on these gradients and these values. So, sure, when we display a height field, we're seeing this in 3D space. We know by looking at the display where it's sloping down. But really, the data on here, these are not storing point positions in space. This slumping of values is just happening based on, gradients within the height field volume. Now this height field slump here, if you go to the layer bindings, you can see there is a parameter for the material that gets slumped down these slopes, and that's going to default to the mask. And that's why we had to use a noise here to get some initial values into that mask. This slump here, if we didn't really have any values in the mask, it wouldn't do anything. So we need these initial mask values to kind of flow those down the surface. And on this slump control here, there is an iterations parameter that you can adjust. With the hills preset, this is doing 200 iterations, which flows the material down quite a bit. If we reduce that to 100, you can see it's not quite as flowed into those recessed areas. And if we reduce it further, you can see that it's still quite piled up on some of those sloped areas. But I kind of like what this preset's doing. At 200 iterations, that looks pretty good. It's also worth pointing out that this height field slump node isn't just defining the mask to exist where we have these recessed areas. It's not like we just see our standard height field shape with the mask region, confined to these more recessed regions. It's actually, kind of simulating some mass buildup in those areas, depending on how much, runoff that we've had into these regions. So you can see, when we unbypass this node, it's actually filled up with mass, which is really cool. And, just this would be a nice improvement to our height field so far, but this does look a bit smooth, and this could use some additional breakup for, more realistic visual interest. So we can add a little bit more noise on here to finesse this some more. Now this height field isolate layer is essentially, throwing away the height values that we've had in here. It's just isolating the mask values themselves. It's, outputting this mask value as a height. So whatever accumulation we've calculated here, the mask stores the amount of accumulation. So in these deeper values here, that we have a higher mask value at the center and, lower mask values here, where it's, accumulated a little bit less material. There's a lot more material accumulated in the very center, so this has a higher mask value. So when we use this isolate layer to just show us the mask values that have been computed, just show us how much mass we're filling in there, that's why we get these little troughs like this, because those deep recesses have filled up with a little bit more material. So it's kind of an interesting way to visualize what we just calculated. Now, if we add an extra height field noise to this, that's going to kind of rough it up a little bit more. It's kind of subtle. If we zoom in and I bypass this, this hills preset calls it rocks. It's just really some interesting detail. And you can see that this one also has the second input connected, and this second input here helps to provide an additional mask input to only apply the noise in certain areas. So in this case, we're just adding this extra rock detail noise where we've accumulated this stuff. We don't really want this extra detail added elsewhere because we've already handled that detail in our main setup here. And we've got lots of nice detail on most of our terrain controlled by this roughness. We only want this detail masked in these newly added areas. So now that we have our old height field and these new values here, we can simply add those together with this height field layer node And this layer mode is set to add. This is almost like compositing different height fields together. So it takes the height from this and the height from our original, adds those together for this nice result like so. So if I kind of zoom in on this area, you can see this is what that extra detail's adding, which is quite nice. It doesn't look very realistic when we leave it smooth like that. So now we're finally getting some pretty nice looking terrain that's going to serve as a pretty decent environment for our scene. Now this hills preset has one more interesting node here. It's this height field erode node, and this is essentially a simulation to simulate the weathering of this terrain over time. Now I didn't really feel like these extra details were necessary for this particular scene. I'm kind of already happy with the shapes that we're getting here, and it's, looking like a pretty nice terrain as it is. So I didn't really bother to include these details from this simulated erosion, but if you display that and play through it, you can see it's, building up some areas where water would run off and accumulate and erode that terrain, and it looks pretty cool. So you can certainly feel free to experiment with that if you'd like. I didn't bother. I just used this as, our main shapes here. So yeah, feel free to have a play with that if you'd like. Although, yeah, certainly feel free to just use it at this point here without any of that simulated erosion. One thing that's good to watch out for with any type of Houdini network you're dealing with is this icon here that indicates that this node is time dependent. So, this is running a simulation, so that's why it has this little clock icon here that indicates, this output of this node is changing over time. You can see all of these other nodes upstream from that, they don't have that little clock icon here, because these are just sort of static. They're going to be the same all the time, no matter what frame we're on. So it's good to be aware of, what parts of your scene are time dependent, because sometimes there are some issues where, you'll have things changing every frame when they really don't need to, and that can really slow your network down. And I'm sure that's something that'll probably come up later in the course. But yeah, worth mentioning that as something to watch out for, particularly if something in your scene is processing much more slowly than you would expect it to. So yeah, this is, a pretty good point for our initial terrain generation. We're going to do some more modification where we cut out an area of interest and we do a little bit more procedural modeling to work on like a river running through this thing, but I think that's enough for this video, and we'll save those terrain modifications for the next video. Actually, I do want to add one more comment before wrapping up this video here, and that's to say that I'd like to see everybody at least use some different offsets on these height field noises. Don't feel like you have to put a ton of work into designing a very different looking terrain. By all means, feel free to change up the terrain as much as you would like, but at the very least, try to use some large offsets on these noises so that your version of the terrain at least looks a bit different from everybody else's and a bit different from mine. You can see when I set 2000 and the X offset of both of those noises, we get a significantly different variation, which will also probably lead to, carving in a river in a different place as well. And it just helps to make your shot a little bit more unique.